Friends, up to last lecture we see all the topics related to two-dimensional system. So today we are going to start 3D, that is three-dimensional system, that means three-coordinate system. So today we see next topic, vector in two dimension, that is 2D. Let x o x dash and this y o y dash be the rectangular coordinates axis in xy plane. So we consider this x axis and y axis. Let I cap j cap be the unit vectors along positive x axis and positive y axis respectively. So that point which we consider must be in first quadrant, that is unit vectors consider along positive x axis and positive y axis. Let p of xy be any point. So we consider here point P in plane xy. Draw Pm perpendicular to x axis and Pn perpendicular to y axis. So from P we draw perpendicular on positive x axis and on positive y axis. Then OM is equals to x and ON equals to y. Here we consider Cartesian form. So this distance must be, so this is Pm. Instead of Pm we consider parallel to it ON. So this ON must be y, that is distance on y axis, and this OM, that is distance of that point P on x axis, that is x. So OM equals to x, ON equals to y, and vector along this x axis, unit vector along this x axis is I cap. So we write this vector OM as x I cap, and this vector ON, unit vector along this positive y axis, is j cap. So ON bar or vector ON can be written as y j cap. Now OP bar equals to OM bar plus MP bar. We have to calculate the value of vector OP. So we go from O to M and then from M to P. So we write here OM bar plus MP bar. This MP which we replace by ON. So OM bar plus ON bar equals to xi plus yj is a vector in 2D. So this point P represent in vector form as r bar equals to xi plus yj, because we consider vector OP bar, that is position vector of position vector of P with respect to is r. So we write here r bar equals to xi plus yj. So similarly we discuss about three-dimensional system. So instead of P of xy we have to take P of xyz. Here we consider two coordinates. In three-dimensional system we have to consider three coordinates. So see, three dimension, that is 3D. So coordinate system, because we have to write if the points are in Cartesian form. So from that Cartesian form we have to write its vector form. So coordinate of a point in a space. When we consider three coordinate system, then point is in space. When we consider two coordinate system, that point lie in a plane. To express a vector in space in terms of unit vectors along coordinate axis, we require a rectangular coordinate system in three dimensions. So because when we represent a point in space, space means three coordinate system. Consider xy plane bounded by the x and y axis. So this xy plane which is bounded by x and y axis. Draw a line ZO Z dash perpendicular to xy plane and passing through the point O. So this xy plane we draw a perpendicular ZO Z dash passing through origin O. Let P be any point in space. Here we consider point P in space. Draw PM perpendicular from P to the xy plane. So we draw perpendicular from this point P on this xy plane at point M. Then ON and NM are the x and y coordinates of M in xy plane, which are denoted by x and y respectively. So ON and NM, this ON and this NM are the x and y coordinates of that point P in xy plane. The sign of z coordinate is positive if MP is in the direction of OZ. This MP in the direction of OZ. If this in opposite direction, then we write its sign as negative. Thus a point P in space has coordinate x, y, z. The coordinate of M are x, y, 0. When point is in xy plane, we consider its z coordinate as 0. Similarly, when point lie on x-axis, which we already discussed in 2 dimensions, when the point lie on x-axis is y coordinate is 0. Here we consider space. So when point lie on x-axis, its y and z coordinate must be 0. So see, the coordinate of M are x, y, 0. The coordinate of N are, because this point N lie on x-axis, therefore its y and z coordinate is 0. And the distance of P from xy plane is modulus of z. Why we write here modulus? Because vector in direction of OZ or in the opposite direction of OZ. So we write here modulus of z. Now see next 3-dimensional system, an octet. In 2-dimension system we consider quadrant. In 2-dimension system there are 4 quadrant. In 3-dimension system there are 8 octant. So see, remark, the coordinate of any point of xy plane is of the form x, y, 0 on yz plane, 0, y, z on zx plane, and x, 0, z. So if you observe, when we consider a point in xy plane, the coordinate of that point are x, y, 0. That means in xy plane y coordinate z coordinate is 0. In yz plane x coordinate is 0. In zx plane y coordinate is 0. Any point on x-axis has coordinate of the form x, 0, 0. That means point on x-axis, the coordinate of that point y coordinate and z coordinate must be 0, and its y and z coordinate are 0. Similarly, any point on y-axis has coordinate as 0, y, 0. So point on y-axis x and z coordinate is 0. Similarly, point on z-axis, its xy coordinate must be 0. Third point, distance of a point P of xyz from xy plane is modulus of z. That means distance of point from xy plane is modulus of z. Similarly, distance of point from xz plane, here y is absent, that means modulus of y. Here x is absent, that means modulus of x is the distance of point from yz plane. So in this way you can remember while calculating the modulus of that point from that plane. 3 coordinate planes divide the space in 8 parts. Each part is called an octant. For example, OX, OY, OZ form an octet which is denoted by OXYZ. We denote the octant as follows. So, how to remember? See this table. So, from this table, if the point lie in first octant, that is in O XYZ, so its sign must be plus plus plus. Same we use in 2D. In first quadrant, sign must be plus plus. That means that depend on the whether the point considering on positive axis or on negative axis. So from that we can write the sign of the octant, that point lie on that octant. So in this way we remember these points for calculating the problems. We also discuss these points while solving the problems. So